As we begin our work on transformations, where we start is looking at the graphs of important common functions that you see very often in algebra. The textbook has graphs of these functions. I've attached an extra handout on these graphs in our Blackboard course that you should definitely refer to as you start to work on this material. One difference in the graphs that I have provided is I've included the coordinate points, or 5 pairs of coordinate points, for these graphs. When we do our work on transformations in this section of the textbook, I'm going to stress a tabular algebraic method of applying transformations to these common, or what I usually refer to as the base functions f of x. We then apply different transformations in different sequences to arrive at a final graph of the transform function. But where we start in these problems are with these 5 coordinate points. Now, my handout includes all the same common functions you will see in the textbook. So you'll see here the identity function, or remember, an f of x really you can substitute as y. So y equals x. There's our y equals absolute value of x. There's our quadratic function, y equals x squared. The cube function, y equals x cubed. And then we have our square root function and our cube root function. Those are really the functions that we are going to focus on. It'll be very important that you essentially have these graphs memorized and know their basic shape, domain, range, characteristics, but most importantly is knowing the coordinate pairs that will allow you to get started when we do transformation problems with these functions. Now, memorizing the points that you see here isn't necessarily required. So one thing I want to emphasize is for any of these functions, while it is good to have the points memorized, of course, remember you can always fall back on the point plotting method we saw in section 2.1, and you can use this for any function, not just the functions you see here, but any function really in algebra or higher level mathematics. You can always create a table of x, y coordinates by selecting x values, substituting them into the function, and then evaluating the function, getting your y values, and putting together the x, y values as coordinate pairs. Let me show you an example of how you can use the point plotting method for these functions to generate the 5 coordinate pairs we will use in our transformation work with the base function. So let's say we want to have a problem with, say, the quadratic function. So f of x equals x squared. So I can create a table of coordinates. Right, here's our function, y equals x squared. And because it's the quadratic function, I'll pick those 5 typical x values that we will use from -2 to 2. And then all I'm going to do is substitute these x values into whatever equation or function we have and evaluate. And now, of course, I can evaluate these y values. This will be positive 4, 1, 0, 1, and 4. And so as you get more used to this process, you can then really make the summarized table. These would be the x, y coordinate pairs that we would graph. So -2 and 4, -1 and 1, 0, 0, 1, 1, 2, and 4. So there's just one example of how you can create a table of coordinates. Why don't I show one more with the cubic function? So let's say we have our cubic function. This is our base function. Again, I can pick those same 5 x values, -2, -1, 0, 1, and 2. And now this will be the cube of these values. And so we create that final table of coordinates, this is what we will get. We'll have our x values and our y values. So we'll have -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. Be careful with your exponents. Remember, a negative value to an odd exponent will come out negative. So I just showed how we can use the point plotting method, selecting those 5 x values, substituting into the function to get the table of coordinates for the base function that we will work on or use for our transformation material. So if you look at our quadratic function, these are the table, all these coordinates are what I created in that table, and the same thing for the cubic function. Again, in general, for most functions, we can always pick those 5 x values from -2 to 2. There are exceptions depending on the function. One I'll mention here, because we do work with the square root function. Remember, the square root, we do not take the square root of negative numbers. Those are not real values. We're working with real values at this point. So in this case, notice I do not have -2 or -1 as x values. I have to start at 0. So I do generate 5 coordinate points. But here, the 5 x values we use are 0, 1, 2, 3, and 4. So just be careful. With some functions, say as the square root function or even the reciprocal function, you cannot use 0 as a value. But for the most part, we'll use those 5 x values of -2 to 2. So just keep that method in mind so you are able to generate these initial table of coordinates to use in our transformation material.